Hello everyone, it's Harsh Kataria and welcome to my YouTube channel. Today we'll be talking about another important topic in feature engineering, that is feature scaling. But before we jump into it, I would like to ask you to hit the subscribe button and to stay tuned for all the future videos I'll be uploading. In this session, we'll be talking about three important aspects. First of all, why do we need to do feature scaling? The second topic we'll be covering is on the ML algorithms which require feature scaling. We have studied a lot of different ML algorithms like linear regression, logistic regression, decision trees, KNN, K-means clustering. So for which ML algorithms do we need feature scaling and for which we don't? There are few algorithms where feature scaling doesn't have an impact, but there are few algorithms which are impacted by doing feature scaling. The third one is about a very important topic of standardization was normalization. We know that for feature scaling, we generally use these two techniques, and but generally people don't tend to understand what is the difference between the two. So we'll be covering these two in detail. Let's start with the first thing, which is why do we need feature scaling, right? So consider an example where we have a data set which has height and weight of individuals and we are calculating BMI, right? Now every feature, as you're talking about feature scaling, we are dealing with different features, right? And every features has two properties. One is magnitude and second is unit, right? So consider an example here where height is in centimeter and weight is in kg, right? And you are calculating BMI, right? We know that BMI is given by height upon weight square. So if there are some examples where you have height as 180, weight as height as 160, weight as 90 kgs, 60 kgs, and 70 kgs, 175, right? And you want to calculate BMI. Now, height and weight are independent features, whereas BMI is an output feature. Now you can understand that if you are gonna plot this variables where height is on the y-axis and weight is on the x-axis, you'll have 180 cross 90 somewhere here, right? There will be 160 cross 60 and there will be 175 cross 75, right? Now depending on units, right, you can have meter as well here as a unit, or you can have kilometer as a unit. Here you can have grams as a unit, right? So the magnitude will vary depending on the unit, right? So it might happen that these points may be farther if you are capturing this in kilograms, in grams and centimeter. These distances what you see right now are small, but if you translate it to in this range, this the points might be very far off, right? And if you are there are a lot of algorithms which are based on Euclidean distance, right? What is the distance between the 2 points? Just like we have k nearest neighbors, then we have k means clustering, right? These are the algorithms which are work dependent on Euclidean distance, right? So if the Euclidean distance is more, it will take a lot of time for these algorithms to converge, right, and create a model, and it will not be faster. Hence what we need to do is we need to do feature scaling so that we can scale down these values. So it's very important to scale down these features into something like 0 to 1, so that it helps us understand, okay, we have a good starting initial point so that these algorithms can converge faster. Another example which we can take is linear regression, right? Linear regression works on gradient descent, where you have a parabola and you try and achieve the global minima here. This is the global minima where you want the algorithm to converge, right? Now, initially we start with a random arbitrary point, right? As we do gradient boosting, we start moving, we take an initial point and we start moving to different points until we converge at this point, right? Now this optimization can take a lot of time if these values are not scaled up, right? If these values are on different units, it might happen that you start from a point which is very far from the global minima point, and it takes a lot of time for that you to converge to this point. While if you do feature scaling, you might be starting very close to the minimum point, and you can directly converge it quickly. Hence, it is very important to do feature scaling, right? So I guess you guys now know why do we need feature scaling, and basically it helps you run your algorithms faster and get outputs easily. The second thing what we need to understand is which all algorithms we need feature scaling for, right? So we'll calculate, create two columns where feature scaling we require and second feature scaling is not required. So all the algorithms which work on Euclidean distance, right? Such as KNN, then we have K means, then second is on gradient descent, algorithms working on gradient descent, right? We have linear regression, we have deep learning techniques, deep learning, where we have CNN, RNN, where there are in CNN we use unit scaling where we reduce the pixel size of 0 to 255 to 0 and 1 and calculate, do the training of the model. The second where we don't require feature scaling are mainly the techniques which are tree based, right? So tree based includes decision trees, we have random forest, we have XGBoost. So all the bagging and boosting techniques don't require feature scaling. The reason for not requiring feature scaling is they don't work on Euclidean distance. They basically just work on FL statements where we are keep creating decision trees, and they are just cutting the dimensional space with the different conditions. They don't require a distance, right? Hence, feature scaling is not important for them. Now, since we know now which models require feature scaling, let's deep dive into the techniques what we have. So basically, we have two techniques. One is normalization, and second is standardization. These two techniques are often used in feature scaling process. Now, there is a difference between the two. The What are the differences between the two? First is we have normalization. In normalization, we scale down features from 0 to 1. So all the values will be scaled down from 0 to 1 in normalization. However, we do in standardization, we follow standard normal distribution, which means that all the feature, right, will be scaled down such that their mean is equal to 0 and standard deviation is equal to 1, right? So if there are any feature like height and weight which needs to be scaled up, it will be scaled such that the mean of this height would be 0 and standard deviation would be 1. Similarly for weight, right? So we follow this such that each feature should represent a bell curve having a mean of 0 and standard deviation of 1, right? So this is how the scaling is done. Hence, since this is 0 to 1, it is also called as normalization, is also called as min-max scalar, min-max normalization. And we know that whenever we used to convert from normal distribution to standard normal distribution, we used a term called as z-score transformation, right? And hence this method of standardization is also called as z-score normalization, right? Now let's go to let's look at what are the different libraries what we use. So for both of them we use the sklearn library, and sklearn library we have a min-max scaler. for normalization. However, for standardization, we have standard scalar, right? Now, another example, let's understand what are the different formulas for normalization any value, right? We take that value, we subtract it from the minimum value, and we divide it by the difference between the maximum and the minimum value. Similarly, here for standardization, we use a z-score formula where each value we calculate for each value, we calculate z-score, where we take that value, we subtract it with the mean of that feature divided by the standard deviation of this feature. So yeah, this is how standardization and normalization work. Now, one of my personal experience is that I generally find standardization to be working better in most of the cases, but it doesn't mean that normalization is not good. There are few techniques where we use normalization and they give good results, such like in deep learning, where we generally scale features from 0 to 1 because it helps a lot. So yeah, this is how. So in this module, we learned about three different things. First is what is the need for feature scaling. Second is which all algorithms are impacted by feature scaling, and third is what is the difference between standardization and normalization. So yeah, hope you like this video, and please do subscribe to the channel for more such videos. I'll be uploading a lot of different videos on analytics, data science based on my experience. So yeah, till then, happy learning and see you in the next video.